So earlier we saw this identity get derived, that cosine of the multiplying two cosines of different angles together can be written as the sum of two cosines, where one of these angles is the sum of the angles and the other angle is the difference of those angles. Now, what is one of the things that we can do with this is we can solve certain equations. Solve the equation cosine of 11 theta plus cosine of theta divided by 2 equals 0. And we'll do this for all theta. Okay. So, to get a handle on this problem, we have to see that I'm not quite sure how to get 0 out of cosine of 11 theta and cosine of theta. So what I could do is turn this into a product of two cosines, and then if either one of these cosines is 0, then that means that the whole thing will be 0. So if we take a look, I need 11 theta to equal x plus y, and I need theta to equal x minus y in order for me to use this product to sum formula. So what two numbers will add to 11 but subtract to be 1? So if I think about this a little bit, it won't take too long to come up with these numbers. 6 theta and 5 theta would add up to 11 theta, and 6 theta minus 5 theta would subtract to be 1 theta. So if I rewrote this as cosine of 6 theta plus 5 theta plus cosine of 6 theta minus 5 theta over 2, it's a little bit easier to see what x and y are. X is 6 theta, y is 5 theta. So let's write this out. Rewriting this using this identity, this is just equal to cosine of 6 theta times cosine of 5 theta equals 0. So now we have to ask the question, when is cosine of 6 theta equal to 0? When is cosine of 5 theta equal to 0? If either one of these numbers is 0, then the result is 0. So we can break this into two different equations to solve. Cosine 6 theta equals 0. Cosine 5 theta equals 0. So this one, if you think about when is the cosine equal to 0, you can break out your unit circle. So that happens at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So when we do the inverse cosine right here, we're going to get 6 theta equals pi over 2 plus a multiple of pi, basically. Any multiple of pi. Now we divide everything by 6. That gives us theta equals pi divided by 12 plus a multiple of pi divided by 6. So that's half of the answers. Over here, when is the cosine of 5 theta equal to 0? Again, same idea. 5 theta needs to be pi over 2 plus a multiple of pi. So we have 5 theta equals pi over 2 plus n pi. Divide both sides by 5. Hold on a second. And you get theta equals pi divided by 10 plus n pi over 5. And so the combination of these two sets of numbers comprise all of the solutions to this equation. You plug in pi over 12 plus any multiple of pi over 6 into here, you'll get 0. If you plug in pi over 10 plus any multiple of pi over 5, you'll get 0. That's all of the possible answers.